Good morning, everybody. Good morning. Myself, Vani KS, Department of Information Science and Engineering, Nitya Meenakshi Institute of Technology. So today I'll be covering about few topics about supervised learning, classification algorithm, and in detail about decision tree algorithm. So let us start with what is this classification will come under supervised machine learning algorithms. So where under the supervised machine learning algorithms, we also have regression. But in addition to that, particularly we'll be talking about the classification algorithms today. So classification algorithms is nothing but we have some predefined categories, predefined labels in the data set. So given any instance, I should tell to what category or the label the instance belongs to. That is classifying each instance either as A or B or C. So that is called as classification algorithms. So how does it work? Actually, it is, I think here there is an example given, identifying each galaxy as to particular name, or maybe identifying each object as particular category. So like that, assigning some label to every object, this classification we call it as. So it is having so many diverse applications, the classifications. Examples it is written in the slide, detecting the spam email messages based on the message content, or maybe categorizing the cells as benign or benignant based on their some characteristics. So these are something, as I told, classifying each instance as to particular label it is. So for that, these are the examples under classification algorithms. Like decision tree algorithms we have, rule-based classifiers we have, neural networks is also classification algorithms, even though we take it for regression also. Support vector mission, naive-based classifiers, Bayesian belief networks. So many other algorithms are there under classification approach. So generally, how does this classification algorithms work it is? So given a data set, for example, let us assume that we have 15 instances in the data set. 15 rows are there in the data set. We have to divide the data set in such a way that we have maximum instances for training, less instances or less objects for testing. So you can see it here, I think 10 instances we have taken for training and 5 instances have been taken for testing. So all these 10 instances, and a learning algorithm will be, this is I am talking generally about the classification algorithms, in general approach it is. So any learning algorithms, maybe it is support vector mission, naive-based classifier, any algorithm it is, can be applied so that the model is learnt, the model is built. So the training data set is given, learning algorithm is applied, we have a model ready. Once this model is ready, we can use this testing instances to apply on this model. We can use this model to test these instances. So what happens during training trial, I give the features and also the labels. But during testing, I give only the features, 3 features which are there, and I ask what is the class. So this is what will happen during testing phase. During testing, I'll give all X and Y. This is called as X, the features. This is called as Y, the label. During training, it will be given both. But during testing, we give only the X and ask what is Y. And then finally, we compare the predicted labels or the labels given by the learned model and compare with the labels which are already there in the data set. Suppose in the data set, we have A, B, B it is. That is the label, and if I get something else it is, I compare out of 5 labels, how many are correctly predicted. So if 5 instances are there and 4 are correctly predicted, the accuracy of this learned model will be 4 by 5. That is 5 test instances are there, out of that 4 are correctly classified, 1 is misclassified. Then that time the accuracy of this learned model will be 4 by 5, that is 90% it will be. So 80% is the accuracy. So that is how we calculate the accuracy of a classification model. So coming to the algorithm, particularly about decision tree learning. So as I told, decision tree is a classification algorithm under supervised learning. This is one of the mostly used algorithm for classification, a very good learning algorithm. Decision tree is an overall concept. Under that, we have these many algorithms like ID3, Assistant and C4.5. The difference between all these algorithms lie in the way how the tree is constructed, decision tree, how it is constructed. Let us see it in the next slide, how does it constructing. So based on how the decision tree is constructed, how the node is constructed, the root node is considered, these three algorithms, there are differences. So decision tree is one concept. Under that we have ID3 assistant and C4.5. Three algorithms are there under that. So for example, it is if I take some data set of a popular data set called a sunny data set, or maybe the weather forecast data set, this will, using the training data set, this is a decision tree which is constructed. Suppose if I have 4 or 5 features, I think I'll show you the data set. How this is the data set. So this is the data set. For example, if 4 features if I have, out of those 4 features, which should be considered as a root node here. Yeah, so taking that data set, the training data set, using the 4 features, we took Outlook as the root node it is. So here particularly I am talking about an algorithm called as ID3. ID3 stands for Iterative Dichotomization version 3 algorithm it is. So out of those features, why Outlook only was chosen as a root node? Because there is some concept called as entropy and information gain calculation. So that calculations, we'll see it later how to calculate that entropy information gain. So the entropy and information gain is calculated for all the 4 features in the data set. Then whichever feature has the highest information gain, so that node will be considered as a root node it is. So then like similarly other like the step by step Outlook, all the possible features were sunny, overcast and rain. That is, in that particular column we had 3 possible values, so meaning 3 branches has to start. Then once it is done, the next level which node should be considered as a next deciding node. Again, out of the remaining 3, like 4 attributes were there, we are done with 1. So out of remaining 3 attributes, we calculate again which is having the highest information gain. Humidity has the highest information gain. Then the possible values of humidity were high and normal. Possible values high and normal, so 2 branches will come out. Then finally, these are the decision labels, or these are the labels which are there in the data set. So this is how decision tree will be constructed based on entropy and information gain calculation. So based on that calculation, this ID3 algorithm we have discussed. Like C4.5, one more algorithm I told, or maybe assistant algorithm. These use some other strategies called a split ratio and so on. So based on that only the decision tree will be constructed. Yeah, so this tree, whatever we have constructed it can be called as a disjunction of conjunctions it is. The decision tree can be told as a disjunction of conjunction. What is that conjunction? One branch we call it as conjunction. For example, here I call it as this as one branch. That is, in the sense I can write it as an if-else statements. The entire tree can be written as a range, as a sequence of if-else statements. So for example, how do I write this one branch? If Outlook is sunny and it's a conjunction, so it is and humidity is equal to high, then the label is no. So that is one branch is called as conjunction, or one more is the disjunction. That is one more branch, how can I write? One more conjunction, how can I write? Outlook is sunny and humidity is equal to normal, then yes it is. So every branch here is a conjunction. As many branches are there here, we call it as a disjunction of many conjunctions it is. So this is one branch, or that is another branch. Outlook is overcast. This is one branch, or Outlook is overcast, or one more branch I can write, or it's again a disjunction of many conjunctions here. Outlook is equal to rain and wind is equal to weak. Outlook is equal to rain. Outlook is equal to rain and wind is equal to weak, then the label is S. So this conjunction of disjunction of many conjunctions, it is written for the label called as yes it is written. Now that's what I told. How do you classify, how do you understand which attribute is the best classifier here? If you have 4 features in the data set, which do you consider as the best classifier? So for that we consider something called as information gain. This is with respect to the ID3 algorithm. ID3 algorithm, we used information gain. Maybe Gini index and Gini will be used in some other algorithm. Like Gini index and split ratio will be used in another algorithms called as assistant and C4.5. So to decide which attribute is the best classifier, we use information gain. The attributes which has highest information gain will become the root node. Now, how to calculate entropy entropy, it is written the entropy of the whole data set it is. Entropy is nothing but the amount of impurity present in the data set. So how do you calculate entropy of a particular data set is nothing but proportion of positive sample, log 2 of proportion of positive samples and so on with negative samples it is. So that is how the entropy is calculated over a whole data set it is. So entropy is nothing but the amount of impurity present in the data set it is. So what is the impurity like? How can I tell? 0 to 1 is the amount of impurity present. The entropy of 0 indicates all the samples are belonging to one particular label. That is entire data set is having 0 as a label or maybe S as a label or no as a label. If entropy is 1, the meaning it is totally impure. So in the sense I can conclude like this. Entropy 0 means all the samples are pure. In the sense all the samples in the data set are either of S or of no or any one particular label. So then the entropy of the data set will be 0. Entropy of a data set when it will be 1 when it is totally impure. In the sense equal amount of positive and negative samples will be there in the data set. So when it is impure meaning equal number of instances will be there. So entropy decides what type of data set it is, whether it is a pure data set in the sense all the samples belong to one label or it is a mixture of all the samples it is. So based on that information gain calculation will be done. This I will be covering it in the next session. Gain calculations which will help us to decide what is the root node. So once the root node is calculated, the rest options depends on the information gain calculation of all the remaining attributes. Thank you.